David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Okay, let's look at a working definition for a piecewise function. It's going to look very similar to a composite function with one difference. First off, it's a composite function that's built from two or more, that's an or, separate functions. Now here's the new part, where each function has its own domain, which are the x values of the function. All right, let's take a look at one of these types of functions. F of x, that's the name of this function. Now, it's telling us two separate functions. So here are the two functions. At one point, it's 2x plus 5. That's a linear function. And then at another point, it's 1/2 x plus 3.5. So we're defining this function as two separate functions. And then we talk about having different domains or different x values. So it's 2x plus 5 for x being greater than -3, but less than or equal to -1. So for that domain, for that range of values for x, the function is 2x plus 5. But as soon as the function gets bigger than -1, now it's a new function. It's 1/2 x plus 3.5. So that's the idea of a piecewise function. It's two functions that are pieced together rather than combined into one. They're actually spelled out, again, for different ranges of x, different domains. All right, let's take a look in Desmos and see how this comes out graphically. All right, so here I am in Desmos, and I've got my graph, and I put the first function up here. This is y equals 2x plus 5. But now I need to specify the range. We don't want the whole function, or I'm sorry, I should say we need to specify the domain. It's a little confusing because I say the range in x values, which is accurate, but then range also refers to the y values. Okay, so to do this, I'm going to type my curly brackets, I'm going to open, and I'm going to type in my first expression, which was -3 less than x, which is less than or equal to, and we had -1. And so notice now on my screen here, it's limited that linear function just to the range that I put in there. So in Desmos, to do a composite function, I'm just going to go ahead and hit enter at the end of the line over here on my first function, open up a new line, and type in that second function, y equals, and that was 1/2 x plus 3.5. And now you can see that this function is a linear function as well, and it's just cruising along to infinity, both negative and positive. So what we need to do is pop in here and specify its range as well. And in this case, all I did was say x has to be greater than -1. So there we go. Now notice a couple things. This function down here at the low end of the domain, it stops. It stops at the point -2 -3 -1. And it goes all the way up to the x value of -1 where it stops. And that's where our second function kicks in. Now, it's going to go all the way to infinity because I didn't specify an ending range. So if I zoom out, you can see this function does not stop. This line is just going to go on forever. So what I want to do now is pop back over to the board and show you how to put this function into a hand graph if you're putting it on a test. Right, here is what it looks like in a hand graph transferred onto a piece of paper. Notice how I have my linear function here. That's the first one, the 2x plus 5, cruising along like that. And then I wind up with my second one cruising along like that for its domain. Okay? So check this out. There's a couple subtleties. That's an open circle because x is greater than -3. It's not greater than or equal to. This one is less than or equal to -1. So that's a solid circle. That's a solid dot because this is just the function going through that point. Notice how the function ends here, but it has an arrow there because x is greater than -1. It's just going to go on forever. So that captures that. Now to be thorough with my graph, I labeled my obvious points. So I have minus 3, minus 1. I have minus 2.50 there. I have negative 1, 3 there. And then I have my y-intercept for my second function there. All right, check this out. Here's another one, another piecewise. My first function is a quadratic function. Check that out. X plus 2 squared minus 2. And here is the domain for that, the x values that we're allowing. So x just has to be less than 1 and bigger than negative 4. So that's where this equation holds. The second equation is just 7. What does that mean? Think about that real hard for a second. Okay, so when f of x equals 7, that's just a horizontal line of y equals 7. Remember, f of x stands for y, so y equals 7, and that's going to pertain for the domain where x is bigger than 1 but less than 5. Okay? So, what I want you to do All right, let's see how you did. So here's my hand graph, and it looks pretty much like the Desmos graph. And check it out. Notice how my x values here, I don't get my minus 1 for x, or my minus 4, or my positive 1. So I've got open circles here and here. Now, this circle could be closed if this was greater than or equal. If x was greater than or equal to 1, that also would cause that circle to be closed, but it's not. So that stays open, and then also x has to be less than 5. It can't be 5, so that circle is open. Let's talk about the labeled points. So my vertex, I just got right here from my vertex form quadratic, so that gave me that vertex. My 1, 7 comes from the end of the vertex, not the end of the vertex, but from vertex form. When x is 1, I put 1 into my function, it's going to kick out 7. So that gets me the 1, 7, which is also on this function here. Now we go all the way over to 5. We're going to stay with y equals 7. So that one's 5, 7. And then my y-intercept is 0, 2. That happens when I put x in, or 0 in for x. I'm going to get 4 minus 2 is 2. So that's that point, 0, 2. Now, you might think you want to get the x-intercepts, but if you remember from the graph in Desmos, they are not integers. You could find them, no problem, but I don't think this graph needs those unless it said find the intercepts. All right, in case you're wondering, we can do more than 2. So I'm going to have you do one with 3 functions. There we go. We've got an exponential function there, 2 to the x, for all the x's being less than 1. Then we have 2 linear functions. We have minus 1/2 x plus 2.5 for x's that are greater than or equal to 1 but less than 10. And then our last range is, it's just x minus 12.5 for when x is between 10 and 15. So now I want you to pause the video, jump over into Desmos, and put all of that in. Let's see how you did with your hand graph. So check it out. Same shape we saw in Desmos, so I faithfully copied that over. Notice how here I have an arrow. It means that the exponential part of this function goes forever to a negative infinity. All that has to be, x is just less than 1. Okay? It can't be 1. But for our second function, x can be 1. So this is solid for that reason. Now we have our linear function with the negative 1/2 slope. That's sloping down. It goes all the way down here to 10, 2.5. That's an open circle because x is less than 10 here and x is greater than 10 in our third function, but it never can be equal to 10. So that's why I have my open circle there. And then, of course, now we have our third function, x minus 12.5. That's shooting up with its positive slope, and it ends at the point 15, 2.5, because x cannot be greater than 15, but it can be equal to 15. So that's a solid dot. Now check it out. I got a bunch of points for free. I know my exponential function is going to go through 0, 1. I marked that. I could tell that point is 1, 2. That's right off the graph in Desmos. Same thing with this 5, 0. That's easy to read. In fact, the rest of these points are easy to read right from Desmos. You can also confirm them in your function just by doing a few substitutions with the end members of your domains. Okay, so one last thing here. we want to specify the domain and the range of this function. So we want to say what are all the possible x values and what are all the possible y values. Remember, domain is all the x's that can be used in this function, and range is all the y's that can come out of this function. Now, this function is a little more complicated because it's actually built of 3 separate little functions in our piecewise function. So if you're feeling bold, pause the video and just make some notes. Don't worry about notation yet. Just see if you can figure out any limitations on the domain and on the range of this function. Okay, let's see how you did. Check this out. Broad strokes, big picture. X can never be bigger than 15. In fact, roughly speaking, x has to just be negative, or not negative, but less than 15. Our arrow there indicates that it goes all the way to negative infinity, so there's no limitation in the negative direction. It's just it can't get bigger than 15. So x is less than or equal to 15. Now there's one more exception. X can never be 10. Notice how we get close to 10, but it's always less than 10 here, and it's always more than 10 here. So we listed x not equal to 10. So that's good enough. I like to be thorough, so I also wrote x as an element of real numbers. You could put any number in for x in these functions and get out a valid y. So you could put pi in, you could put all these weirdo irrational numbers like root 2. It works just fine. Okay, now that you've seen how the domain, the x values are specified, pause the video and think about the y values or the range. Let's see how you did. So this one's a little different. Broad strokes. Y is never going to get more negative than negative 2.5. This function just does not exist lower than that point. Likewise, the function does not exist higher than 2.5. So the y values are constrained between positive and negative 2.5, and it can't be negative 2.5, but it can be positive. So that's why what I put is y is greater than negative 2.5, but less than or equal to 2.5. And then, of course, I added my y is an element of real numbers. So this is how you might specify the domain and range for this piecewise function. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.